Maybe if you are 10 and then 5 are males, 5 are females, you can be able to say 50% are males, 50% are females, or you can say the sex ratio is 1:1. You get it? So by the time you have processed it and you may are trying to make meaning out of it, that has become information. Hope you get it. So statistics has to do with activities that are related to the collection, organization. There is also summarization, which is not reflecting here in the definition. Summarization, analysis, and interpretation of data, medical or health data, or you can also say data collected from biological sources. That is human beings, because we have a lot of types of statistics, but in our own case, we're interested in the medical statistics, which has to do with data that is related to human beings, medical or health data. Do you get it? So, and the statistics is broadly divided into two. We have the descriptive statistics and the inferential statistics. So when you are just interested in collecting the data, collating it, and then summarizing the data, it has to just do with descriptive statistics. But when you want to go further and make meaning out of that data, make decision about a research question or inquiry based on that data that is collected, that is what inferential statistics is all about. So usually, even even though you've not done a project, but I'm sure you have some idea about research, and you know that in research you don't study everybody in the population. It is neither necessary nor feasible for you, because you want to do a research, for you to study everybody. Let me just give you a simple example. For instance, now the burden of hypertension. If you are reading a medicine, surgery, or any other subspecialty, I'm sure you used to see a section on, let's say, hypertension. You usually see epidemiology of hypertension, right? What are the risk factors for hypertension? What are the modifiable and non-modifiable risk factors? So all those things, even the cutoff values, they were gotten out of a research. It was out of research that people were studied, and then they'll be able to generalize it to the population. So you see that a sample of a given population is being studied, and then findings of that study is being generalized to the reference population where that sample is taken, and then you'll be able to make conclusions regarding that general population. So by the time you're just interested in collecting the data, analyzing and summarizing the data, it stops at descriptive statistics. But when you are trying to make meaning out of it, make decisions about maybe a research question, you are trying to say a project, maybe you are trying to find out what are the factors associated with utilization of antenatal care services, for instance, in Kano State. So when you want to make decisions about those questions, like what is the level of utilization of antenatal care? We all know that some people go for antenatal care while some do not go. So you want to know, first of all, what is even the prevalence of the utilization? How many pregnant women in the state go for antenatal care? And then what are the factors that are responsible for the utilization? That is reasons why women go or do not go. Do you get it? So by the time you have gone into that, you study a sample of pregnant women, and then what you find, you cannot, it's not possible, neither is it necessary for you to study all the pregnant women in Kano State for you to make that decision. So when you take a sample of those pregnant women, with the caveat that you use probability sampling technique to study those women, you'll be able to generalize your findings, what you found from that um, group of pregnant women. You can be able to generalize your findings to other pregnant women in the state. So that is what inferential statistics is all about, and it has to do with two major things: hypothesis testing and confidence interval estimation, which we'll be talking about in subsequent sessions. Okay, so when you collect the data, let me just differentiate between collection and collation. So for you to do any research work, you need to, like I said, calculate a sample size, the number of people that you'll be studying. That is what you call the sample. When you take a sample of the population, for instance, those pregnant women that I said you select and study, so that is the sample. So by the time you collect, let's say you calculated that your, based on previous studies, you calculated your sample size to be like 450 pregnant women, and you are going to develop your study tool, which is a questionnaire with a set of questions you'll be asking those women. So by the time you finish collecting that data, that is administering the questionnaire to those pregnant women that have consented to participate in the study, that is collection of the data. So when you finish collecting the data, you have interacted with all those 450 women. You now have to come, if it is depending on the type of data collection that you have done, whether it is manual or now that we are having some advancements, whether it is you are using electronic devices, things like ODK. I don't know if people know it. It's like software that you input all your questions, and you using an Android device to be able to fill those questions, and directly it will enter the question and download them into an Excel sheet when you are done. So if you do a manual data collection, you print the questionnaires and administer the questionnaires to them, meaning that you will have to come and do data entry into a spreadsheet like Microsoft Excel. That I'm sure you know, because I'm sure you are conversant with computers. So collation. So collation is putting them together and entering them into a spreadsheet like Microsoft Excel. Then you now come to the level of analysis. Doing your data analysis using softwares like AP Info, SPSS, Minitab, a whole lot of them. So that is it. Collection, you collect it. Collation, you now put it in a spreadsheet, and then you now analyze the data. Then you now make meaning out of it. Is it clear up to this level?
Yes, ma'am.
Yes.
Okay. So how is medical data classified? So data is recorded on a day-to-day basis in industries, a lot of settings, medical settings, hospitals, occupational health settings, etc. So for instance, examples of what you can get employee social demographic characteristics. And social demographic characteristics basically have to do with the issue of usually we don't collect people's names for a study, but you need to collect like age, sex, um, ethnicity, religion, level of education, occupation. So those are what we call social demographic characteristics. Do you get it? Income, level of education, address, all those things, ethnicity. So those are some social demographic characteristics. And anthropometry, like weight, BMI, level of
Hello? Sorry, ma, we can't hear what you're saying. I don't know, maybe if it's network, but we can't hear what you're saying. Hello? Maybe you can try, maybe see if it's muted. So maybe you can try and unmute. I don't know.
Can you hear me now? Hello?
Oh, yeah, we can hear you now. We can hear you.
Okay. So at what level did you stop hearing me?
The previous page. Where was it?
Hmm?
It was at the previous page when you were talking about let me see, I can't remember. How data is being recorded. That's where it went mute. When we were talking about the XLE, so when we use
Okay.
Excel, since we know how to use computers and all of that, that as well.
Yeah. So did you get the part of data collection and collation, difference between collection and collation?
Yes.
Okay. So that's fine. Like I'm now at the level of describing what variables are.
Okay, no problem. Thank you. You
So
can continue.
variables are okay. Yes, variables are characteristics with respect to which statistical units differ. So like the example I was giving, you can just come to that your class now, and we want to say we are study participants. So each and every one of you is a statistical unit. Do you get it? And the example I gave regarding those pregnant women, any single pregnant woman is a statistical unit. Do you get it? And they are not the same. One is different from the other. So they are statistical units. So variables are characteristics with respect to which statistical variable units differ. Do you get it? So in simple terms, what makes one individual different from the other? Do you get it? So, and the data, those variables are divided into two. This you need to really get it because this is the basis of statistics: quantitative variables and qualitative variables. So the quantitative variables are the ones that you can be able to count. They have numerical dimension, while the qualitative variables are attributive or categorical in nature and there is no numerical dimension to them. Going further, these quantitative variables and qualitative variables are further divided into two, both of them. So the quantitative variable examples include weight, height, anything you can measure. Weight, height, radiation level, humidity, pain score, temperature. Do you get it? Anything that you can be able to attach a numerical dimension to it is a quantitative variable. And they can be further classified into discrete and continuous. So the discrete quantitative variables are the ones that can only take integer numbers. They can only take whole numbers. For instance, number of women, number of babies delivered by a woman, or age in your at your last birthday. Do you get it? That is maybe you say 20 years, but by the time you are adding um the months on top, it is no longer a discrete variable. So discrete variable are the ones that take only integer number, while the continuous they are the one that can take decimal values, like blood pressure, height, weight. You can take it to the up to the point, that point up to infinity, 50.698. Do you get it? Meters, or 58.999999 kilograms. So they are continuous variables. While the qualitative variables are divided into nominal and ordinal. So the nominal are those ones that do not have any superiority over one another. For instance, skin color. Just because you are dark or you are fair, you don't have any. It doesn't have any no superiority. Or issues like religion. Do you get it? Issue of ethnicity. All those ones, they are nominal. So there is no superiority of one variable over the other. While the other one, the ordinal, that is ranking. So it could be ordered. That is severity, for instance, severity of injury, um, like um, like cancer. You can say grade 1, grade 2, grade 3, or you can say mild, moderate, severe level of pain. So there is order or ranking in those the second type of the qualitative variable. So taking it again, quantitative variables are divided into discrete and continuous, while qualitative are divided into nominal and ordinal. So these are the things you can be seeing in your MCQs for the types of variables. So now taking us to summarization of those data, you can be able to summarize whether it is quantitative or qualitative. You can be able to summarize it using three things. I hope you are taking notes. This, what I'm about to say now, is not written on the slides. So you can summarize those variables, whether they are quantitative or qualitative, using numbers, tables, or charts or graph. Three things. You can summarize it based on numbers, based on using tables, using charts too. Those are the three things you can be able to summarize your data with. So I think if we all have our pen and biro or and paper, you can be able to draw. Let's have a 3 by 3 table, so that we can have the methods of summarizing the data on the first column. The second column we can write quantitative, and the third column we can write qualitative. Can you hear me?
Yes, ma'am, we can hear you.
Okay, just to summarize it, because they usually play around with these ones in MCQs. They will give you a quantitative variable, and then they will ask you, you can summarize it using so. Then they will now list it in the MCQs for you to choose the right option. Do you get it? So you can summarize. You remember I said biostatistics has to do with collection, collation, summarization, and interpretation of data from biological sources. So now we are talking about how you are going to summarize those data. So you can imagine collecting information from 450 people. So you cannot just be sitting down there and be looking at what the information about those people individually. So you need to put all the information about those 450 people, you put it together and then make meaning out of it, which you will further extrapolate to the general population. Do you get it? So what are the ways that you can be able to, that data that you have collected, how can you summarize, present it? So for quantitative variables, there are ways you can summarize and present the data. For qualitative variables also, there are ways you can summarize it using the numbers. So you can summarize using numbers, using tables, and then charts and graphs. And there are different numbers, different tables, and different charts for the quantitative and the qualitative variables. Do you get it? So for using numbers, for quantitative variables, you can be able to summarize your quantitative variables. Have you drawn the table?
Yes, ma'am, we have a 3x3 table, right?
Yes. So for the first box, that is the first cell, you write numbers, which is one that we are going to discuss now. Numbers. So if you remember from our mathematics, we have our measures of central tendency and measures of dispersion, right? Do you still remember them? Measures of central tendency and measures of dispersion. Do you still remember them?
I would
This is
say
basic mathematics.
I would say the information has gone into so it would require a bit of revision on them.
Yes, we definitely discussed, but I just want to know if you still remember them. This is basic mathematics. That's why they said before you enter university, you have to have a credit in maths and English. Is that not so?
Ma,
Yes?
please, can you use the whiteboard for the demonstration, please?
Okay.
That's ma'am.
Okay, so for the for the measures of the central tendency, who can remind us what it is? Anybody?
I can't say we know, but I know.
Mean, mode, median.
Yes, mean, median, and mode. Those are the measures of central tendency. So in statistics, we'll see it in the subsequent slides that are going to come up now. We have what we call the normal distributed data, and we have what we call the skewed data. So for the normally distributed data, when all our information that we collect, if they are like close to each other, if they are not like skewed, let's say like now income, some people can be earning like 50,000 in that your class. Some people can be earning, let's say, 50,000, then some people can be earning up to 1 million naira. Do you get it? So all the values would be concentrated towards one value, but if they are close together, those are the ones that we call the normally distributed data. So for quantitative variables, you can be able to summarize them using measures of central tendency and measures of dispersion. So the measures of central tendency are the mean, the median, and the mode, while the measures of dispersion, also called the measures of spread or measures of variability, they include the range, the standard deviation, the interquartile range, semi-interquartile range, variance, and coefficient of variation. I hope I'm not too fast.
Sorry, could you repeat the method of dispersion again?
Okay, range.
Yes.
The first one you need to know is here on the screen, the standard deviation, right? Then the range. Others include interquartile range, semi-interquartile range, coefficient of variation. You remember the relationship between standard deviation and variance, right? Variance is another measure of dispersion. Standard deviation is the square root of variance.
Sorry, ma, could you repeat what you just said?
Standard deviation is the square root of variance.
Oh, the square root of variance. Okay, standard deviation.
This is basic maths now. So for each quantitative variable, you usually summarize it using one measure of central tendency and one measure of dispersion. Do you get it? And and the one that is commonly used is the mean. If the data is normally distributed, usually biological data, or data collected from biological sources, almost all of them are normally distributed, as in they are usually almost uniform for individuals. For instance, age now. In that your class, now those people that have graduated, of course, sometimes we can have some outliers, but then usually you see you would be from the same similar age brackets. So now if you take age now, you would say, I mean, it's average. So you usually summarize that variable using one measure of central tendency and one measure of dispersion. So for normally distributed data, you use mean and standard deviation. Do you get it? While for the data that is not normally distributed, you use median and range. Please write that down. Mean and standard deviation, then median and range or interquartile range. Do you get it? So let me give you an example. Mean is usually the central value. So if now, let's say in that class now, I take what you said you are now 10 in that class. So if I ask every one of you, how old are you? How old are you? Everybody tells me his age. So for instance, now 10 of you, we have the ages of the 10 people in the class. So by the time we put all the ages together and now divide by 10, we'll be able to get the mean value. That is the central value. Then the standard deviation is the one that is telling us how spread those individual values are away from the mean value. So if the average age in that class is 25 years, for instance, let's say the mean age is 25 and the standard deviation is 2, so you will write it as 25 plus or minus 2, meaning the age of doctors in med tutors ranges from 25 minus 2 to 25 plus 2, meaning it ranges from 23 years to 27 years. Do you get it? So the standard deviation of 2. So it means the youngest person in that your class is 23 years, while the oldest person is 27 years. Do you get it? So that is how you summarize it, with our sample now being 10. 10 people, you have summarized their ages. Mean age of doctors in med tutors is 25 years plus or minus 2 years. So by the time you write that, everybody knows the youngest person is 2 years and the oldest person is 27 years. Do you get it?
Yes, ma'am, we do.
Okay, then the median is the one that if the values are scattered around. So the median is the central value. You mentioned the central value. Then the range is just the highest minus the lowest. That is how you present the skewed data. Do you get it? While for qualitative variables, you can summarize them using ratios, proportions, percentages. So ratio is just like I mentioned, let's say among those 10 students, there are 5 males, 5 females. So the ratio is 1:1. Do you get it? Then proportion is when the number of people that have the attribute of interest divided by the total number of people that you are studying. The proportion, when you multiply by 100, it becomes a percentage. So those are the 3 ways you can be able to um, summarize qualitative variables, just like it is written on that slide. Frequencies and proportion. Frequency is just numbers. If you just count how many males, how many females. So those are the frequencies. 5, 5. So by the time you want to now take it, what is the proportion of males in the class is 5/10. Do you get it? That is 0.5. If you multiply by 100, it becomes a percentage. 5/10 times 100, 50%. Hope you get it.
Yes, ma'am, we do.
Okay. So now what are the kind of now tables? What forms of tables can you use to summarize quantitative variables? They are called frequency distribution tables. So you just draw a table, write maybe age from this age group, and you have for grouped and for ungrouped data. I'm sure you are reflecting your mathematics now. Frequency distribution table for grouped and for ungrouped data. So if it is for a group, you want to count the number of people that are aged 23 years in that class. So you just write the frequency, the age on one side and the frequency, how many people are aged 23 years, count them and write as simple as that. Well, for groups, you need to, that is one that has class intervals from 23 years to, that one is a small range. But let's say you have up to like, you can say from 15 to 20, 20 to 25, 25 to 24, sorry, you don't want to overlap, 25 to 30, that 31 to 35, although those ones are grouped and you want to count number of people that are within that group. Do you get it? So for tables, it was frequency distribution table for grouped and for ungrouped data. While for qualitative variable, we have three types of tables. We have simple tables, we have contingency table, and complex table. Do you get it? Simple table, contingency table, and complex table. So a simple table, just like it is mentioned, just if you are trying to just count, let's say sex, you want to count how many females, how many males. That is qualitative variable. Gender, so you write males, 5. Write the frequency and write the percentage. While for contingency table is usually a 2 by 2 table where you are presenting um, up to 2 variables. So maybe you want to write a table, you want to cross tabulate a table that is showing sex and then religion. So on the columns, you can present the sex as male and female, then religion, you can write Muslim and Christian. So among those people in the class, how many males are Muslims, how many males are Christians, how many females are Muslims, how many females are Christians. Do you get it? So two types of variables presented in a single table. That is a contingency table. While complex table, when you have more than three variables and above, if you are writing the information, qualitative variables. Do you get it? Okay.
Yes.
Then for charts and graphs, just like I said, please pay attention because sometimes you can see this in MCQ. They can write a type of table for you for quantitative, and then they will be asking you, you should choose all the things that you can be able to summarize quantitative variables with. So for summarizing quantitative variables using charts and graphs, your options are histogram, or you have this line diagram, which usually shows trends, like number of cases, like this diphtheria now, number of cases, you are showing trend, the number of cases there over time. Trend of rates over time is for line diagram. You have box plot, which is also called box and whiskers plot. You have scatter diagram or scatter plot, which shows the relationship between two variables. Let's say you want to plot the relationship between height and weight of doctors in med tutors. You see, there are two quantitative variables. So you want to be plotting the intersection. So for a given a single person, you plot his weight and height. So height on x-axis or weight on the y-axis. So the relationship between two quantitative variables, they are the ones that you show on scatter diagram or scatter plot. Then another one that is not written on the slide, we have this cumulative frequency curve. I'm sure you still remember it. OGIF, cumulative frequency curve. Do you get it? Okay. Then you remember our histogram, and when you join the midpoints and plot it, you superimpose a frequency polygon. So I'm taking it again: histogram, frequency polygon, scatter plot or scatter diagram, line diagram, box plot, cumulative frequency curve. Do you get it? These are the options for quantitative variables. While for qualitative variables, we have the pie chart. I'm sure we remember the pie chart, the bar chart, the pictograms, and the spot maps. So usually for variables that are less than, if you are presenting data that is that have less than 5 groups, it's better you present them using pie chart 3. No, but if you have up to more than 5 categories, it's better for you to use a bar chart. You get it? So do you still remember the difference between a bar chart and a histogram?
By Amolet, I want you to know that. Okay, sorry.
So bar chart has spaces in between the bars, while the histogram, there is no space, in case you see it in picture test. The bar chart has spaces because you are just representing categories or groups, while for the histograms, usually the endpoint, you plot the midpoints of the class intervals. So usually the bars are connected. There is no any space between them. I think there is a picture. Let me move forward. Okay, so this is a table, categorical data. This is frequency distribution table for ungrouped data. Are you seeing it? This is for grouped data. Example I give 20 to 39, 40 to 50. This is a
We
simple
can't
bar
see it.
chart. The screen is not showing.
It's showing now.
Okay. It's showing, right?
Yes, ma'am.
Okay, let me move back. The tables that we've been discussing, this is a frequency distribution. This is a frequency, a simple table, right? Just the level of education, no formal education, primary, secondary, tertiary with their frequencies. You get it? Well, this is a frequency for quantitative variables. You remember I said there are 2 types: frequency distribution table for grouped and for ungrouped data. So this is for the ungrouped data, where you just write the number, and how many children are in the family. Those that do not have children, you just write the number. But this is for grouped data. Okay, I was telling us the difference between a bar chart and a histogram. So a bar chart has spaces in between because it's just showing us categories. How many people do not have formal education? How many people have primary level of education? How many people have secondary and tertiary? So the spaces in between the bars. Do you get it? While for histograms, you see that they are close together. So by the time you plot the midpoints, you can be able to superimpose a frequency polygon. That is for a quantitative variable. Do you get it? This is a box and whiskers plot. So usually it shows the median. There is a 25th percentile. So for a given data set, you divide it into 100. You have this is the range, the lowest and the highest, 0, 100. Then you have the 25th percentile. Median, I said, is the 50th percentile, right? Halfway. Then the 75th percentile. This is box and whiskers plot. This is a scatter diagram. Okay, I gave an example using height and weight. This is another example using blood pressure and age. So usually describe the relationship between two quantitative variables. So if you see the values are moving, as one is increasing, the other is increasing, that is a positive relationship. While as if one is decreasing and the other one is also decreasing, it's a negative relationship. While if there is no relationship, you see that it will give us a parallel line. Do you get it? So any question
Yes,
up to
ma'am.
this level?
No, no
Any
question.
question up to this level? We'll be moving to probability. Can we move?
Yes, ma'am.
Okay, so for the purpose of this, what we have discussed so far
Yes.
now is for you to be able to know for each quantitative and quantitative variable, which are the numbers for quantitative variables and quantitative, which are the tables, which are the graphs. So that is it. You can see them in MCQs. Then in probability, you should know that we have, what is probability? Let me just hear from the layman's perspective. Mm?
The chances of occurrence of a random event.
Okay.
Yes.
That is perfect. You have mentioned it. That is chance. That's the probability. That's the chance of something occurring. Do you get it? So for the purpose of our exams, we should know that we have three definitions of probability. We have two events and two laws. If you know that, we are home and dry. Because you know our exams are MCQs, right? So we should know that there are three definitions, two events, and two laws of probability. So if we remember, we like he rightly mentioned that what is the chance of occurrence of a given random event. So we have the classical definition, we have the frequentist definition, and then we have the subjective definition of probability. So what the classical definition is just saying is the normal definition that we used to know of probability. Total number of favorable outcomes. So anything that is occurring is either it occurs or it doesn't occur. Like these lectures that we are having now. So before we started the lecture, we have two things. Either the lecture holds or it doesn't hold. Do you get it? So it has two possible outcomes, either the favorable outcome or the unfavorable outcome. So for the classical definition of probability is the total number of favorable outcomes divided by all possible outcomes. And I remember in mathematics, they usually ask us what is the probability. There are in the bag, there are yellow balls, there are blue balls, there are red balls. So what is the probability of choosing a blue ball? Do you still remember those mathematics class? Well, ask you what's the probability of choosing a blue ball. So it's the total number of favorable outcomes divided by all possible outcomes. That is the classical definition. And this definition is usually restricted because it can be difficult to apply to an infinite population, like the population that you don't know the probability space, which is all possible outcomes. Do you get it? So sometimes it's very difficult for you to know the probability space, which is for an infinite population. You cannot be able to apply it to an infinite population. So sometimes in such situations, you take a representative sample. The absence, then you now observe the relative frequency of the event of interest. And that is what is called the relative frequency. The second one, the frequentist definition, which is the relative frequency definition. So you now take the number of favorable outcomes divided by the sample size that you took. That is, if you take a sample of the population. Because if you repeat it on a larger population, the estimate should be closer to that of the total population. Do you get it? While the subjective definition, which is also called, which you usually use your intuition, is usually a subjective. It's based on one's degree of belief in the certainty of occurrence of events, usually using your cumulative experience or your intuition to assign probability to an event without conducting an experiment. For instance, if you normal labor lasts 10 hours, right? 1 centimeter per hour dilatation. So if a pregnant woman comes like 6 centimeter dilated, based on your experience, you can be able to say she will deliver in the next 4 hours, right? Or that the number of that a woman can the possible gender is either a male or a female, unless of course there is congenital abnormality. Do you get it? So probability is usually reported as a fraction or a percentage. So, and some probability is always positive. So it meaning that it ranges from 0 to 1. So if a probability is 0, it means there is no chance of occurrence of the event, meaning that you are certain that the event is not going to occur. While if the probability is 1, you are certain that the event is going to occur. So we have what we call complementary probability, which is the probability of occurrence plus probability of non-occurrence, which would when you put it together, it's going to give you 1. The probability of occurrence is P, while the probability of non-occurrence is Q. So meaning that mathematically, if you write it, P plus Q is equals to 1. So if you put it 1, if probability of occurrence is 0.3, it means the probability of non-occurrence is 0.7. Putting them together, it will give you 1. Do you get it?
Yes, but I have a question. Are you still on that first slide that says probability outline?
Yes, well, I'm speaking to the slides. I've finished defining. I've told you what classical definition is. I have told you what frequentist definition is.
Yes.
And I have told you what subjective definition is. And then I'm telling you some general things about probability, that probability is always, I'm just trying to make life easy for you, not to bug you with other things that you need on the slide.
All right,
If you remember, you told me exams is in 3 weeks.
Yes.
So just I hope you people are writing some things down. I don't want to bother you with things that you may not see them, because the nature of our exams is MCQs, picture test, and orals. Do you get it?
Yes, thank you.
You don't have, if I'm moving the slides, you see this is long English classical definition. Do you get it? Hope you are seeing.
Yeah, yes.
So that's why I just want to give you the things you need.
All right, thank you very much.
So the things I've mentioned on this slide, I said in probability, what you need is these 3 things written on those slides: definition, events, and loss. So I said there are 3 definitions of probability: 2 events and 2 loss. I went further to tell you that probability is always positive. Do you get it? It ranges from 0 to 1. If it is 0, you are certain that that event is not occurring. While if it is 1, you are certain that the event is taking place. Do you get it?
Yes.
And I said probability is complementary. P plus Q is equals to 1. P is the probability of occurrence. Q is the probability of non-occurrence. By the time you put them together, they will add up to 1. So I gave example, if the probability of occurring is 0.3 or 30%, what is the probability of non-occurrence?
70%.
Okay, what of if it is 40%? What is the complementary probability?
60.
If it is 35?
65.
Good. So that is just what is simply telling us that probability is complementary. It's either a proportion or either report it as a proportion or you report it as a percentage. Do you get it?
Yes.
And probability is always positive. You cannot say is minus something. Do you get it? So these are the things you can see in MCQ. Probability is always a positive. Do you get it?
Yes, ma'am.
Okay. So coming down to the types of events that you can have, this one I remember there was a time they asked this in an oral exams. What are the two types of events of probability? You have two types of events. You have the mutually exclusive event and the independent event. Two types. What is a mutually exclusive event? So two events are said to be mutually exclusive if the occurrence of one event prevents the occurrence of the other event. Do you get it? So now, let's say if you toss a coin, it can either be a head or a tail. The two things cannot come together. Or if you are going for a wedding and a lecture, you just have to choose. You cannot be at a wedding and you cannot be at a lecture at the same time. Physical lecture, not virtual lecture, because if it is virtual lecture, you can be attending the wedding and then just join the lecture. Do you get it? So one event, if it prevents the other event from occurring, it is a mutually exclusive event. Do you get it?
Yes.
While an independent event, just that like it sounds, it is said to be independent if the one event in no way affects apply to it is the additional law of probability, meaning the probability because two of them cannot occur. You remember we have what we call or and. So for mutually exclusive event, so you say probability of event A is either A occurring or B occurring. They cannot occur at the same time. So if you want to get the probability, you'd say the probability of A occurring plus the probability of B. Do you get it? So it is the additional law of probability that is applicable to mutually exclusive events. While for independent events that they can occur at the same time, it is the multiplication law of probability that applies to it. So you say probability of A times probability of B. Put it together. Let me give you a simple example, like what is the probability? So if you go to the GOPD, General Outpatient Clinic, if you select one patient at random, that patient can either be a male or a female, and at the same time, the patient can be hypertensive, can be diabetic. Nothing stop that person from being a male or a female and then still being a hypertensive or diabetes. So you would want to know what is the probability of a patient selected at random from a general outpatient clinic being a female hypertensive patient. So you maybe let's say there are 50 patients in that clinic and you want to choose one person. What is the probability that a person is a female hypertensive? So you say the probability of being a female patient times the probability of being a hypertensive patient. Do you get it? Because nothing stops you from being a male and being hypertensive or being diabetic at the same time. Do you get it? Independent events, you multiply them together. For mutually exclusive events, because they cannot occur together, you add. This is an MCQ question. It can also come in orals. Can I move?
Yes, ma'am.
Okay. So this is basically what you need in probability. Do you get it? I've discussed all this.
No, we
Addition
can't see
law.
it. The screen is not sharing again.
Hmm?
The screen isn't sharing.
Isn't sharing?
Yeah, it stopped like 2 minutes ago or so.
Okay, don't worry, I'll send it immediately, but finish discussing. But I don't know why it's not showing.
Maybe you can
Let
go
me
back
share.
on sharing screen again.
Is it sharing?
Yes, it's back.
Okay, so I didn't even move the slide. Everything I mentioned on this while this slide was on. So you can go over it when I send the slides. So 3 definitions, 2 events, and 2 laws. That is just it. I said for mutually exclusive event, you do additional law, right? While for independent, you do multiplication law. This is only thing you need here. Do you get it?
Yes.
Okay, then this slide 2, types of the probability distribution, how they are shown. You remember I told you that those types of quantitative variables that I said there is a discrete and continuous variables, right? Those variables that take only integer numbers, they are the discrete, right? While the ones that can take decimals are the continuous variables. Do you remember that? So for those kinds of discrete variables, the types of probability distribution are the binomial. The acronym I usually give them is PBG, President of Great Britain, in case you see it in MCQs. Binomial distribution, Poisson distribution, geometric distribution. The only one that you may see in exams is this normal distribution table, normal distribution. Did you hear me?
Yes. Yes.
Normal distribution. Are you seeing the slide 29?
Yes, it's showing.
Types of probability distribution. For discrete types of variables, those that can take only integer number, you have 3 types of distribution: binomial distribution, Poisson distribution, and geometric distribution. They will not bother you with this. But for continuous probability distribution, we have the normal distribution, the exponential distribution, and the logistic distribution. The one that they will ask you, if they are going to ask you, is the normal distribution.
Okay, thank you.
You get it?
Yes.
It's a common exam question. What are the properties of normal distribution curve? So a normal distribution is the function that tells the probability that any real observation will fall between any 2 real limits or real numbers. So the person that discovered it is mostly attributed to this Gauss. That's why it is also called Gaussian distribution. So you would either see normal distribution or Gaussian distribution. And it is the most famous probability distribution. Do you get it?
Yes, ma'am.
So this slide, you can either see it in MCQ, you can see it in orals, you can also see it in OSCE. They can decide to tag it as one of the stations. This normal distribution curve. This is how it looks like. Are you seeing it?
Yes.
Okay, so this one in statistics is a common question. What are the properties of normal distribution curve? This slide 31, sorry. So this is the list. It describes, like I said, it describes continuous random variables, right? Those that they can take decimals. So if you look at the drawing, it is bell-shaped, dome-shaped. You can see dome also, DOME. It's either dome-shaped, bell-shaped, or perfectly symmetrical. So it is symmetrical about its mean. So meaning the mean is the central value. Mean is at the center. So it's symmetrical about its mean, meaning that one half is the mirror image of the other half. If we say something is symmetrical, right? One half is the mirror image of the other half, right? So it is symmetrical about its mean. It is bell-shaped. You can also see dome-shaped. And it divides the curve. The mean divides the curve into two equal halves. Another property is that the total area under the curve is 1. You have to cram these properties. The curve is completely defined by its mean. In some places, you will see mean and standard deviation. Some places, you will see mean and variance. And I have told you the relationship between variance and standard deviation, right?
Yes.
Okay, so anyone you see, it is correct. It is fully defined by its mean and standard deviation. Another property is all measures of central tendency coincide at the same point, meaning that the mean, the median, and the mode are equal. Do you get it? For a normal distribution.
Oh, okay, yes. For a normal distribution, yes.
Yes. Then there is one of it which is called the standard normal curve, which is the father of the normal distribution curves. That standard normal curve has a mean of 0 and standard deviation of 1. Do you get it?
Yes.
Okay. Then this other one, the last property is that 68%, 95%, and 99.7 lie within plus or minus 1, 2, and 3 standard deviation of the mean respectively. Let me break it further. You see this midpoint? This is the
Yes.
mean. You remember I said the curve is perfectly symmetrical, right?
Yes.
It is divided into 2 by its mean, meaning that one half is the complete mirror image of the other half.
Yes.
It is
Yes.
fully defined by its mean and standard deviation.
Yes.
All measures of central tendency coincide at the same point.
Yes. Mean, mode, and median. All of them are in the middle.
Yes. 68% of observations, for instance, if you are studying, let's say, a class of primary 1 pupils, there are 100 in the class, and you want to guess what is their mean age. So 68% of those observations, we have 100 people in the class. 100 people are the number of observations. Do you get it? So it
Yes.
means 68% of those students, their age will lie within 1 standard deviation, meaning it will lie from this. You see this mean? Are you seeing this cursor moving? This is
Yes.
mean, the central point. This is
Yes.
minus 1 standard deviation plus 1 standard deviation. This is 68%. From here to here is 68%. So meaning
Okay.
68%, what is 68% of 100? Is 68 students, right? So it means the age of 68 people will lie within the mean
This.
age and 1 standard deviation. While 95% of those children in the class, their age will lie within 2 standard deviation on either sides of the mean. And 99.7 will lie within 3 standard deviation on either side of the mean. So you can see it as a simple calculation. They will ask you, how many, so if the mean age, primary one pupils, I think they're like those kind of children that are 6 to 7 years, right? In primary one, naturally.
Yes, ma'am.
Okay, so if let's say the mean age of those pupils is 8 years, the mean age of pupils in primary one in Med Tutors Primary School is 8 years plus or minus 2 years. Do you get it? So breaking down this rule, it says 68% of observations lie within one standard deviation on either side of the mean.
Okay.
So it means 68 students, because I said the sample size is 100 students, right? So it
Yes.
means 68 people in that class, they will have ages ranging between 6 years to 10 years.
9
Do
they go.
you get?
Okay, in the 95%.
No, the mean age is 8 years and standard deviation of 2. I
Okay,
said
yes.
8 years plus or minus 2.
Yeah. So it will be 6 to 10.
6 to 10.
So 95 students will be aged
No,
between
not 95. 68%. What is 68% of 100?
68.
The students are 100 in the class. This is simple mathematics, because in the exam they will not come and just ask you one direct question. They can put it in a form of simple calculation. If there are 100 people in the class, what is 68% of 100?
68.
Or let me make it 120. Somebody should divide. What is 68% of 120 students?
120 times.
We'll be finishing in the next 5 minutes because it's time for prayers.
Yeah, 81.6. That's 82, I guess. 81.6.
Okay, round it up.
82.
82. So it means out of those 120 students in that class, 82 of them, their age will range from 6 years to 10 years. Do you get it?
Yes, that's
Do you get
using
it?
standard deviation. Standard deviation of 2. Using standard
Yes.
deviation.
The mean is 8. Standard deviation is 2.
Okay, yes, I understand.
Are you the only person that is understanding? Please, I need confirmation from other students.
Tariq, Alpha. Tariq, Halima, Hafsa. Alpha, no?
Ask them, do they understand?
They are listening. Go.
No, it's not about listening. Let them get it.
I would love it if you could re-explain that again, because you are confused.
Pardon?
I would love it if you could re-explain it again, please.
Okay. So I said, but you know what is mean, you know what is standard deviation, right?
Yeah. Yes.
What is mean? The average value or the central value? Standard deviation is how those individual values are scattered around the mean. So now, in that your class in Med Tutors, how many doctors are you in the class?
I think we're like 30, 40 there about. Let's just say 40.
40, right?
Yeah.
Yeah, 40. Do you get it? So it is not possible for all of those 40 people of you to have the same age. Do you get it? It's not possible for all of you to have the same age. Do you get it? I'm telling
Yes.
you real life scenario.
Yeah, I understand so far so good. Yes, I understand so far so good.
And you cannot have the same weight, all the 40 of you. Everybody is unique in his own way. You have different heights, you have different weights, you have different ages. These are 3 examples of quantitative variables. Do you get it?
Yeah, height, weight, and age, 3 different variables.
And it is a type of distribution curve that you remember in this first point that I mentioned. This type of distribution is the one that summarizes continuous random variables, and these are all of them are continuous variables. Age is a continuous variable. Do you get it? Weight is a continuous variable. Height is a continuous variable. Do you get it? And all of you, you are statistical units. These 3 things I have mentioned are variables, and the variables, there is no way 2 people can be the same. So in those, among those 40 doctors in MedTutors, you have different ages. But now it doesn't make sense for me to be coming and writing the ages of 40 doctors, or the weight of 40 doctors, or the height of 40 doctors. You need to put it concisely, the way it will summarize and make meaning. Do you get it? So in that your class now, I want to summarize your age now. The mean age of doctors in your class. Do you get it?
Okay. Yes, I'm with you, ma'am.
Okay. So let's say the mean age is, let's just say, is 25 years, hypothetically. The mean age, average age of those 40 people in your class is 25 years. And the standard deviation is 5. Or let me say 3. The standard deviation is 3. The average age is 25. The standard deviation is 3 years. So it means the age of doctors in that class in MedTutors ranges from 25 minus 3 to 25 plus 3.
Yes.
Who is the youngest person in the class?
It's going to be 25 minus 3, that's 22 years old.
22 years. What of the oldest person?
That will be 28.
28. 28. Does everyone get it up to this level?
Yeah. So far. So far, so good, yes.
Okay. So this law that I'm explaining now, that those 40 doctors, the age of the 40 doctors is the observation. 40 people is the observation. So now, if I say 68% of 40 doctors, what is it? What is 68% of 40 doctors?
27.2. So that's
27.2. So human beings cannot be decimal. Round it to the nearest whole number.
I'm sorry. Let me just pause you people here. Sorry. When you say
68 divided by 100 times 40 is 27 doctors.
Okay.
Do you get it?
Yes.
So out of those 40 doctors in your class, this rule says 27 of you people will have an average age of 25 plus or minus 3.
Yes.
Meaning the youngest doctor will be 23 and the oldest doctor will be 28.
22.
Do you get it?
Yes.
Then 95% of observations will lie within 2 standard deviations. So what is 2 standard deviation from that 25?
That will be plus minus 2.
Plus or minus 6. Because your standard
Oh,
deviation
okay.
is 3. What?
Now
3
I get.
times 2 is 6.
Yes. I see.
So it means so 2 standard deviation is plus or minus 6 years.
Yes. So
While 3 standard
95% of doctors
deviation,
be aged
95%
between
of those doctors. So you now say what is 95%? You say 95 divided by 100
yes,
times 40.
0.940.
38 people.
Yes, 38.
Almost everybody,
Yeah.
38%, 38 doctors will now have their age. Average age is 25. It will remain 25. But the
Yes.
youngest person is going to be 25 minus 6.
Yes. Yes, 25 minus 6,
And
that's
the
9.
oldest person is going
The
to
oldest will be
that's
25 to
19-year-old, right?
19 to 31.
19 to
31.
good. Then 99.7, which is almost 100%, is almost
Yes.
40,
Yeah,
all
just-
those doctors
Mhm.
will lie within 3 standard deviation, which is 25 minus
That's
9.
9.
3 standard deviation
That's
is
9.
9.
Yes.
So there is no way the youngest person is going to be less than 25 minus 9 years.
Yes.
And the oldest person
Yes.
is going to be 25 plus 9.
Yes, I understand.
That is what we call properties of normal distribution.
But this law only applies if the population that is being like the population you're using sticks to the properties of having normal distribution curve,
Very, very good. Exactly, you get it.
Yeah, thank you.
So that is what I'm saying. You can see it in a simple question now in MCQ. They will now ask you how many people have weight, our age ranging from 21 to 26. So the first thing is for you to look at the mean and the standard deviation. So know which one is 1 standard deviation, know which one is 2 standard deviation, know which one is 3 standard deviation.
Yes, I
It's a
understand.
simple calculation that can come.
Yes, I understand.
Is it clear?
Claire, I can't speak for the rest.
So tomorrow morning when you come for discussion, ask them if it is not clear. Since you have gotten it very well, please try and make them understand.
Oh, sorry, man. Is that's the first thing is going to be tomorrow morning? I can
First
promise
thing
you.
in the morning, please
problem.
use weight as example. You can take 50 kg. Do you get it plus or minus 5 kg and
Yes.
use it?
No problem. No problem.
So this is for, I will send the slides this evening.
I think
can go through them.
I will use example for like a bag of rice or cement. On the bag they write 50 kg plus minus 1. That will be easier.
Right, it means that cement can either range from 49 kg to 51 kg. That is
Yes.
what it means. It will start making meaning to you now.
Yeah.
Do you get it?
Yes. This is nice.
So this is another last thing you can see in MCQ. For the one that is not normally distributed, you remember in the normal distribution I said all measures of central tendency coincide on the same point, right?
Yes.
Okay, for the one that is not normally distributed, this is how it looks like. It can either be skewed to the positive skewness or negative skewness. Do you get it? You see it?
Yes.
Okay. So for a positive skewness, mean is greater than median and median is greater than mode. So usually what I do, I usually flex my hand, just like the greater than sign. So mean is greater than median and median is greater than mode.
Okay.
They will play with your intelligence here.
Now, so let me try to understand. Mean, the average is greater than the middle, and then the greater than the mode is Baba minus Karami. All right.
Yes.
I understand.
Okay. Then for the left, for the negative skewness is mean
It's
is
going to
less than median, and median is less than mode.
the opposite.
So for a positive skewness, the mode is the biggest.
Yes.
While for the negative skewness, the mean is the least.
Yes.
So that brings us to the end of the lecture.
All right. Thank you. Sure.
So if there is any question, you can quickly drop it.
I don't think there's going to be any question. I think if there's going to be any question tomorrow after, and then maybe I get confused in the process or something.
Okay, no problem. In case if I will talk to them so that they can add me on your WhatsApp group. If there is any question, you can drop it on the group.
All right. Thank you very much.
I wish you all the best.
Much.
Apa?